Alright, video 3 guys. Now we are going to be having two radical expressions, and we're going to be multiplying those together. So if I look at this first one, it is the square root of 8 times the square root of 8. We're going to start off pretty simple, not simpler, simple. When we multiply these, we will multiply a coefficient times, a coefficient times a coefficient. Here we don't have any coefficients, so we don't worry about it. And whatever is in the radical times whatever in the other radical. So this would leave me with the square root of 64, because 8 times 8 times 8 is 64. And the square root of 64 is simply just 8, which should make sense because we're multiplying the square root of 8 times the square root of 8. Okay, let's look at a little bit harder one. Now we have the square root of 3x times 4 times the square root of x. So square root of 3x times 4 square root of x. So like I said before, we're going to multiply coefficient by coefficient, and whatever is in the radicand of this one times by whatever's in the radicand of that one. If you guys notice on the first one, we don't have a number as a coefficient. So as always, if you don't see a number, every number has a coefficient. It is just 1. So 1 times 4 would be what's on the outside times the square root of 3x times x. Or in other words, this would be 4 square root of 3x squared. X squared is a perfect square, so I can pull that out. So I'd be left with 4x square root of 3. One more example on the slide. I have the square root of 7xy squared times 5 square root of x. So coefficient times coefficient, radicand times radicand. So no coefficient there, so it is 1. 1 times 5 is simply 5 times the square root, and at 7, x times x would be x squared y squared. So now I look at my perfect squares. I have an x squared and I have a y squared. So I can take the square root of both of those because they are already even. So the square root of x squared would be x, so I'd be left with 5x. The square root of y squared would be y, and I'd be left with just the square root of 7 on the inside of my radical. All right, let's look at a couple harder ones. I have -3 square root of 6x cubed times 8x times the square root of 8x cubed. So as always, I take coefficient times coefficient, which would be 1 there, and a radical, what's in my radicand times what's in my radicand over there. So -3 times 1 would leave me with a -3 times the square root of, well, 6 times 8 would be 48. X to the third times x to the third is x to the sixth. Because remember, when we have x to the m times x to the n, that's the same as x to the m plus n. We add our exponents. We add the exponents together when the bases are the same. And now can I rewrite anything inside my radical as a perfect square? You bet. So this is the same as -3 times the square root. 48 can be rewritten as 16 times 3. And I can leave x to the 6th as x to the 6th because it's already an even exponent. Find my perfect squares. So this will be the same as -3 times, well, the square root of 16 is 4. The square root of x to the 6th is x to the 3rd times the square root of 3. So that would leave me with an answer of -12 x to the 3rd times the square root of 3. Okay, let's look at the next one over here. I have -5 times the square root of 3n times 4 square root of 6n squared. So I identify my coefficients and I identify my radicands. So this will be equal to -20 times the square root of 18n to the 3rd. Because -5 times 4 is -20. 3 times 6 is 18, and n times n squared is n to the 3rd. I'm going to rewrite that as a product of perfect squares. So it'll be negative 20 times the square root of, well, 18 is the same as 9 times 2, and 9 is a perfect square. And I'm going to pull my greatest even exponent out of 9 to the third, so it'll be 9 to the second times 9. Perfect square there, perfect square there. I'll pull both those out. So that's going to leave me with negative 20 times, well, the square root of 9 is 3. The square root of n squared is n times the square root of 2n. Negative 20 times 3 is negative 60. Excuse me. N times the square root of 2n. And that'd be my answer right there. There you go. All right, let's move on to this one. Coefficient times coefficient. Exponent times, or no, exponent, radical times radical. Or radicand times radicand. That'd be a 1 there. So it'd leave me with negative 4 times the square root of, well, 10 times 6 is 60. X times x squared would be x to the third. So it'd be the same as negative 4. Now let's think, how can I rewrite 60 as a product of perfect squares? 15 times 4 doesn't really work. Let's think, 20 times 3 doesn't work. 6 times 10 doesn't work. 12 times 5 doesn't work. Is there any way to write 60 as a product of perfect squares? Well, let's think, 1 times 60, 2 times 30, 3 times 20, 4 times 15. I might have said that earlier. It does work because 4 is a perfect square. So I'd have 4 times 15 times x, and we'll write that as x squared times x. So I'm going to pull out the greatest possible even exponent. Find my perfect squares right there. Pull those out. So I'd be left with negative 4 times, well, the square root of 4 is 2. The square root of x squared would be x times the square root of 15x. And it'd be negative 8x times the square root of 15x would be my answer right there. There we go. All right, last example on this page. Nope. Coefficient times coefficient. Inside the radicand times inside the radicand. Or inside the radical, which is my radicand. All right, negative 3 times negative 3 would be 9. 9. Stop. Write down. 9 times the square root of, well, 5 times 15 would be 75. N to the third. I need to rewrite that as a product of perfect squares. So it would be 9 times the square root of, well, 25 times 3 is 75. And 25 is a perfect square. Times n squared, because the greatest even exponent, times n. Find my perfect squares, which are right there. Pull those out. So I'd be left with 9 times square root of 25 would be 5. Square root of n squared would be n times the square root of 3n. So I'd be left with 45n square root of 3n. All right, there we go, guys. One more example, or one more video of examples, and we will be done with this lesson. Thank you, guys. Hopefully this is all making sense.